So to the cathode, both the hydrogen and the sodium ions will migrate to there. This time the discharge will be determined by concentrations of the ions in the solution, in the electrolyte, not the nature of the electrode, not the position of the element or the cation in the reactivity series.
Why settle for ordinary lessons? Discover a smarter, easier way to learn. This is Muto Online. Get instant access to notes, past papers, and scenario-solved lessons, all tailored as a competence-based curriculum.
Whether it's UNEB prep or just extra practice, we're here to make learning fun and easy. Subscribe now and let's ace those exams together.
Hello everyone. This is Teacher Alan once again, representing Muto Online. We are back to take you through electrolysis. Strictly, we are going to take you through discharge of different ions with the different electrolytes. We've had very many cries of learners who follow us about data, but Airtel is a perfect answer. Airtel has cheap and reliable data that will keep you on, even in live lessons on YouTube. The live lessons we make at as cheap as 2K, you can buy a GB that actually very active data that can work on every social platform. With Airtel, when you use Airtel app, you can as well win prizes, several prizes. Use Airtel app to buy data, to send money across all networks, to buy minutes that can call across all networks. We are back. This time we are going to look at electrolysis this time we are going to use another factor, concentration, electrolysis of concentrated, let's use sodium chloride solution. And this is sometimes known as brine. It is sometimes known as brine. In this still, the electrolyte, we are assuming we are using inert electrodes, inert anodes and cathodes. The electrolyte is concentrated sodium chloride. This means that yes, it is concentrated, but it is now a solution. Since it is a solution, I mean, there is water since it is a solution. So the ions we have, the cations versus anions. The cations, we shall have the hydrogen from the water and the sodium ions from the sodium chloride salt. The anions, we shall still have the hydroxide ions from the water or from the decomposition of water and the chloride ions from the decomposition of the sodium chloride salt. This means these cations will migrate to the cathode. So to the cathode, both the hydrogen and the sodium ions will migrate to there. This time the discharge will be determined by concentrations of the ions in the solution, in the electrolyte, not the nature of the electrode, not the position of the element or the cation in the reactivity series. So since this is a concentrated sodium chloride solution, it contains more of the sodium chloride than the water. So we have more of the sodium than hydrogen. So this means the sodium ions will be discharged by gaining of electrons to form sodium metal, and the hydrogen will be left in the solution since the sodium is more concentrated in the electrolyte than the hydrogen. So the factor now is the concentration, not in the position of the metal in the reactivity series. And then to the anode, both the hydroxide and the chloride ions will be discharged, will migrate to there, but only the chloride ions will be discharged in preference of the hydroxide ions based on the concentrations of the chloride ions in the electrolyte. And since they are negatively charged, the chloride ions will be discharged by loss of electrons to form chlorine gas. And this will happen by loss of electrons. And the loss of electrons, we said this is what? Oxidation. And the gaining of electrons by the cations at the cathode is reduction, since there involves addition of or gaining of electrons. So in this case, we are talking of concentrations of ions in electrolyte. This also has a great application in everyday life. For example, this electrolysis of concentrated sodium chloride or brine is very crucial in the process of manufacturing of sodium hydroxide and chlorine gas, which are very crucial products. We know the sodium chloride, the sodium hydroxide is a raw material in the process of formation of soap detergents. The chlorine is used in the manufacture of bleaching agents such as zinc. The zinc is the chlorine is also used in the decoloration of water in the water purification systems and the soil treatment plants and many other uses. Remember, if you want to keep online watching these videos, Airtel is the answer. It has the cheapest data packs, very reliable. Remember also, their motto is Airtel, the smartphone network. They are very good and nice smartphones that will help you watch very nice videos on very large screens, display screens of the phones. They have a good storage, a very good random access memory that will help you access whatever you want very fast. The videos will not freeze. Airtel, the smartphone network. So we can have another example of electrolysis of molten electrolytes. Let's say electrolysis remember, even as we have kept online, we are capable of posting all videos all the time because of Airtel. They have always provided us with cheap data that help us keep online. Let's talk of electrolysis of molten lead to iodide. Members, this is molten, meaning that there is nothing, it is purely this electrolyte, no water in it. It is purely this electrolyte that has been heated to its liquid form. So the electrolyte is lead to bromide, meaning that the cations present is only lead to ions, and the anions in it, there is only the bromide ions. So once an electric current passes through this one, it will decompose to give lead to ions and bromide ions in it. So this means the lead to ions will migrate to the cathode, where they are going to be discharged by gaining of electrons to form gray solids of lead around the cathode. So we shall be seeing gray solids of lead forming around the cathode. And then we shall be seeing the bromine or the bromide ions migrating to the anode, where they will be discharged by loss of electrons to form bromine, which is a reddish brown liquid. Shall be seeing it depositing around. We shall be seeing it forming around the anode. So for molten electrolytes, we shall only be having ions of that very electrolyte. We shall find nothing like water in it. So with talking about this, we can think of molten sodium chloride. We can think of molten potassium iodide. All of these ones, we shall only have ions of that very electrolyte, that very ionic salt that is making it. Remember, this is electrolysis. Like we looked at the term electro, meaning charge, current, something to do with charge, and lysis, meaning breakdown or decomposition. Remember this in biology. So it's the topic we are talking of. We are looking at how charge is conducted by decomposition of a certain compound. We are online. We said we are a platform that is here to give you free and expensive information for free. All the payback is to subscribe, invite friends, to click that bell so that you can get more notifications. And this is Muto Online, represented by Teacher Anna.